Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. This one's actually quite hard, so think about it. So press pause and have a go. Okay, so to do this, visualize this, visualize this, visualize this as this. So it's 10 to the power of 8 to the power of n, because x to the power of a to the power of b, that's x to the power of ab. So basically break this up into this. So as things stand, this thing here is quite hard to understand what's going on. So we're going to put something simple into the n, so that we get an idea of what's going on. So put something simple into the n, just to see what it would look like. So let's just put something simple in there. Let's say n equals 5. So when n equals 5, 5 factorial will be 5 times 4 times 3 times 2 times 1. And then you've got this thing here times by itself 5 times. So it's going to be this thing here times by itself 5 times. This thing here times by itself 5 times. 1, 2, 3, 4, 5. So in the case of n equals 5, it will look like this. The point here is that up here, n factorial, here when n equals 5, you're going to get 5 terms. 5 terms at the top, and then you're going to get 5 terms at the bottom. 1, 2, 3, 4, 5. So if you have 7 terms, when n equals 7, then you're going to get 7 terms at the top, and then you're going to get 7 terms at the bottom. The point here is that the number of terms here match up. So just bear that in mind. So in the general case, this thing here, hang on. So in the general case for n, the sequence will look like this. N factorial is going to be 1 times 2 times 3 and so on all the way to infinity. Don't forget, n gets larger and larger all the way to infinity. So what's happening up here, n factorial, means 1 times 2 times 3 times 4 times 5 all the way to infinity. And then what's at the bottom here is really 10 to the power of 8, 10 to the power of 8, 10 to the power of 8. It stays the same all the time. 10 to the power of 8, 10 to the power of 8, 10 to the power of 8. What's happening at the what's happening with the denominator is that it stays at 10 to the power of 8, stays at 10 to the power of 8, stays at 10 to the power of 8. Whereas the numerator will just get bigger and bigger and bigger. So the sequence will look like this. You've got one fraction, another one, and another one, and so on. It keeps on increasing, but there will come a point where the numerator will be the same as the denominator. See the denominator here? That's the same as the numerator, because the numerator keeps on increasing. So there will come a point where the numerator will match up with the denominator. And then if you look at the next term, it will be 10 to the power of 8 plus 1, and then this stays the same. And then the next term will be 10 to the power of 8 plus 2, but then this stays the same. The point here is that from here up to here, from here up to here, the numerator here will be smaller than the denominator. But then anything beyond this, remember, n heads all the way to infinity here. So n heads all the way to infinity. So this number here will just get bigger and bigger and bigger and bigger. So from here onwards, the numerator will be much bigger than the denominator. The point here is that from here to here, the numerator will be smaller than the denominator, granted. But then from here onwards, remember this sequence has the ability to go all the way to infinity. So eventually the numerator as a whole will just get bigger and bigger and bigger, much bigger than the denominator. Even though 10 to the power of 8 is a big number, it has the potential to go all the way to infinity. So from here onwards, the point I'm trying to make here is that if you look at the numerator will just get bigger and bigger and bigger, much bigger than the denominator. Even though the denominator starts out as a big number, the numerator will just get bigger and bigger and bigger, much bigger than the denominator. So if the numerator gets bigger and bigger and bigger, if the numerator just gets bigger and bigger and bigger, then of course this limit will just get bigger and bigger and bigger, meaning this limit will diverge because it keeps on getting bigger and bigger and bigger. Okay. If you don't understand this explanation, then track back to the video where I showed you this, where I showed you this. Where I showed you this. If you don't understand the explanation in this video, track back to this video here where I showed you that the limit of this equals 0. It uses the same concept, but I explained step by step for this one here. So if you don't understand this video, track back to this video here. Okay.